Hello everyone, my name is Alicia Mittal and I'm pursuing Masters of Cybersecurity from Deakin University, Downtown's campus. The unit code for my thesis project is SIT723, that is Research Project A. The project that I chose for my thesis stands for Next Generation AI for Adversarial Networks, which is being supervised by Mr. Bob Unger and Professor Yu. Today I'm going to deliver a presentation based on the findings and work done regarding my thesis. The topics that will be covered under my project. Let's move on to the next slide. This slide is about what my thesis project is. What is next generation AI? What am I going to do in that? What have I done so far? So the purpose of this thesis is to develop a network traffic monitoring system to prevent users from cyber attacks, such that the system detects the attack beforehand and try to troubleshoot it, and in case of real-time update, sending data directly to the network admin through it rather than email. Secondly, in order to monitor network traffic, we should be able to capture the real-time data by making use of Python code, for which I use Gene, and later TCP dump and MTR. MTR is the MyTrace tool, which both of them captures the packets. But the difference between the TCP dump and MTR is MTR helps us in sending those scan data in the form of a flat file, that is the txt file, which can easily be sent to the network administrator in case of any issues that comes up while browsing any sites or any vulnerabilities arises. Later, I install a Node-RED. Node-RED is a kind of a cloud that maintains a connection between the Raspberry Pi 4 and the cloud where we will store all the data. So, for this thesis, I have used a Raspberry Pi 4 operating system. So that operating system is just like normal other monitor where we have to install, and it just works like the Windows. So, next thing I will let you know about is the UBDots and the IBM Watson cloud. The cloud that I used for storing all the PCAP data is the IBM Watson and the UBDots cloud. Actually, I used the two clouds in this thesis because UBDots cloud was, the dashboard was quite different from that of the IBM Watson. UBDots give us the opportunities to create our own variables, to create our own devices in easy way. But when we have to add our new device, especially the Raspberry Pi 4 on the IBM Watson, then that's a kind of a thing that we have to spend half an hour. So, in case a person is a newbie, then they can go for the UBDots, and if the person has a lot of time, they can start doing with the IBM Watson. So I did both of them. Next thing is we are not installing any additional software, and Raspberry Pi 4 is really pocket friendly. It is just like a credit card size computer board, which can be connected together with computer LCD or keyboard and mouse to perform like a traditional computer, just as I told you. It is equipped with RAM, hard disk, SD audio and video parts. USB ports are also there, HDMI port and Ethernet port. Let's move on to the next slide. So, what is the problem and what is the conclusion? Well, why am I doing this thesis project and that particular next generation project itself, and what is the conclusion that comes out of it? Actually, the problem is like I'm trying to tell that it's the problem. We try to define the need for the network traffic monitoring system in everyday life, and without it, the problems will arise like congestion if we are not monitoring the traffic. And there are many users that are using the internet at the same time, so there will be a problem like congestion, which will lead to latency and loss of data too, where troubleshooting takes time, as many users are using the wireless network. And network monitoring, traffic monitoring system is like a solution to reduce the congestion after calculating the TTL and reducing the latency by observing the traffic speed alongside the user. By looking at the bytes of the data being sent and received and acknowledgements being sent and received in order to maintain, manage, store, and monitor the real-time data. By sending them to the cloud, to be able to help the users by making use of Raspberry Pi 4. Key point is we are going to develop a network traffic monitoring system to capture the live packets via Python code and using TCP dump and MyTraceRoute for further analysis of the data capture. Alongside, we will perform all this in a separate monitor in which we will first install the Raspberry Pi operating system, which works precisely like the Windows. Later in Pi 4, we will install the MTR, TCP dump, and Node-RED such that we can send and store capture data onto the cloud for future scope or analysis. So this slide is about the goals that I was thinking to achieve and I had achieved already. Scenario A, monitoring the traffic from all the devices, and scenario B is like only from one device we are monitoring the traffic. So what are the analysis? But these two scenarios, as you can see, the scenario A with analysis and result about the Ethernet type 2 frame means like Ethernet framework. The analysis one uses the Ethernet framework, and the scenario B is based on the analysis of the man in the middle attack. So it's the network traffic analysis scenario A, monitoring the traffic from all the devices. In this slide, we talk about decoding the data from different protocols. Decoding the data part of the IPv4 packet is different from all the protocols. The protocol number in the IPv4 header decides how the data needs to be decoded. Decoding the data in TCP segment can be done with the code shown in the picture on the left. After unpacking the data in the TCP segment, it will include all the fields in the TCP segment header as well as the actual data payload. Separating the payload from the header can be done by using an offset, which is calculated from the number of flags in the header. After the headers and data has been separated and formatted, they can be printed out to look similar to picture on right pieces like this. It will show us everything: packets sent by the sender, receiver, the bytes sent by the sender, bytes receiver that receive, and acknowledgement sent by the sender, receiver, what was the largest congestion window size, what was the average receiver, retransmissions, and everything we can get to know about the flow. So next move on to the slide, and with that we will progress towards the scenario B. So scenario B was monitoring the traffic only from a single device. So it deals with the man in the middle attack, which leads to the leakage of data. Actually, I'm trying to depict is from these images is that we can filter our data. We can, whenever we scan, we capture the data. There are some links. The links just like this in the picture to get update, MS download this, and we don't know what this image is. So I've ran through a couple of commands and which gave me this image. Let's move on to the next slide, which is the quantitative. The results in discussion I have divided into two parts: quantitative and qualitative results. As you can see in the previous slide, that it was a qualitative analysis, like I connected UV.'s cloud with the Raspberry Pi, and I also connected the IBM Watson to the Node-RED flow, and I created some small connection to observe the Raspberry Pi's temperature, pressure, humidity, so that I can know like when it will cool down. Otherwise, it can also lead to any kind of heat issues. That's why. So this slide is about the quantitative results. Quantitative results in a sense, like as you can see, there is a sender, there is a receiver, and there is MTR report. So after getting all the data, congestion details, and everything, I send that in the form of a txt file from the sender, which is my account, to my father's account, the receiver email, and I downloaded that attachment, which just looked like this. And we can go to every single details: what was the lost packet percentage, and where what is the congestion, how long it took, and every details, like everything, just like we get in TCP dump, everything is listed here so that you can use it in a later future analysis, or even if we have to conduct any cyber attacks, like if we need to see if any cyber attacks is going to occur, we can just do the behavior analysis based upon these text files too. We can make a lot of future analysis on base of it. And the next slide is about the one I was talking about, the Node-RED flow. So what is this Node-RED flow? As you can see on the left side, The first node is the injection node, the time step. Okay, injection node would injects the messages every 3 seconds from the start. So whatever data it receives from Raspberry Pi, it will show in after intervals of 3 seconds. We will get every data. After 3 seconds we will get another data, which will get another temperature data, humidity, pressure altogether. And the next node is the EXEC node, which runs the function VCGenCMD. So this, as you can see, there's a get CPU temp, that's the EXEC node, and it runs the command VCGenCMD, which gets us the CPU temperature of the Raspberry Pi, humidity and pressure, everything. And the next one is later the function node. As you can see, there is a function node which formats the message dot payload, the data that we, the payload of the data that we retrieve from the Raspberry Pi. And next is the finally the Watson IP node allowed to connect. And there is a Watson IoT IBM IoT device. This is the MQTT node type, which allows to connect the Raspberry Pi to the IoT platform. And after deploying it, we will get a quick start. There will be a video or quick start. A quick start site will open up after we deploy, because I've already put my credentials of accounts on the device, so it will automatically open that device and will show some results, just like as you can see on the right. All the data of the temperature and humidity will cover up in the form of the graphs, as you can see. Now is hacked. So this slide is all about the future scope and further development that can be done in the thesis. The first one is like the email segment. Instead of sending notification via email to admin, we should be able to send notification via web, so that the real-time network change can be detected. Though changes can be tracked manually, this method tends to be time-consuming and often leads to the human error, like missing out configurations or critical network devices while tracking. And the next one, the second one, is being able to get the IP address of the newly added device. Since we know that the get host by address is a method that gets the IP host entry instance from the specified IP address use function. And next is about the expanding the functionality of the Raspberry Pi. By being able to implement a security alarm where the device detects motions by using sensors, and as it detects motion, it starts capturing images which are further stored in the micro SD card, or we can move that images to the cloud as well and send onto a registered. Last is regarding the expanding work on the node-RED.